Some people just seem naturally good at directions, but it's not luck, and it's not magic. If you stay until the end, you'll understand whether spatial intelligence is fixed or fully trainable. Most people think spatial thinking is just about not getting lost. It's much more than that. It's the ability to rotate objects in your mind, to judge distance, direction, and movement. It's what helps you pack a suitcase, park in a tight space, or visualize a 3D structure. Athletes rely on it. Radiologists depend on it. Gamers use it constantly. And this is only the surface. Here's the fascinating part. Your brain literally builds maps. Inside the hippocampus are specialized cells that respond to location. In 1971, neuroscientist John O'Keefe discovered place cells, neurons that fire when an animal or person occupies a specific position in space. Later, researchers identified head direction cells and grid cells. In 2014, O'Keefe received the Nobel Prize for this work. This isn't a metaphor. You carry an internal navigation system. The real question is how detailed your map is. Now comes the controversial part. Does everyone start with the same map? Research suggests hormones like testosterone can influence performance on spatial tasks. In controlled experiments, temporary hormonal changes affected results on mental rotation tests. Some evolutionary theories argue that navigation once played a key survival role. But biology is not destiny, because something more powerful is at play. Spatial thinking improves with training. Construction toys, puzzles, chess, 3D modeling, they all strengthen mental rotation. But action video games show especially strong effects. Studies in the United States found that fast-paced games improve spatial attention and rotation skills. Interestingly, female gamers often show dramatic improvement compared to non-gamers. Practice reshapes performance, not gender, and that changes the narrative. What about so-called directional hopelessness? There is no medical diagnosis called topographical stupidity. However, there is a rare condition called topographical agnosia, usually linked to brain injury, where people cannot navigate even familiar places. For most people, getting lost isn't a disorder, it's a skill gap, and modern life may be widening that gap. We've outsourced navigation to smartphones. GPS apps reduce cognitive effort. They're convenient. But when we rely entirely on turn-by-turn directions, the brain practices less independent mapping. Like any system, it weakens without use. Your internal GPS updates through experience. Without updates, the map stays blurry. We assume some people are born with a better sense of direction, but in reality, everyone has a built-in navigation system. The difference lies in how often it's used, how often it's challenged, and whether we allow it to grow. Spatial thinking isn't a talent reserved for a few. It's a trainable system. And if you get lost often, it may not be your brain's fault.